Question 1. Simplify x squared plus x squared. So we've got 1x squared plus another 1x squared, which makes 2x squared. Question 2. Write 0.4 as a percentage. To change a decimal to a percentage, times by 100. And 0.4 times 100 is 40. So it's 40%. Question 3. Write 5,661 to the nearest thousand. So is it closer to 5,000 or is it closer to 6,000? So we're looking at the thousands column. The next number is a 6, which rounds it up. So it's going to be 6,000. It's closer to 6,000 than it is to 5,000. Question 4. Write 1/4 as a decimal. So what is 1 divided by 4? 1 shared out between 4. So half of 1 is 0.5, and then half it again, which is 0.25. Question 5. Change 2.5 kilograms into grams. Whenever we see the word kilo, K, it means 1,000. So we've got 2.5 thousand grams, 2.5 times 1,000, which is 2,500 grams. Question 6. Write the following numbers in order of size. Start with the smallest number. So I'm going to add some zeros on. So they've all got the same number of decimal places. And so they've all got a 5 in the ones column. In the tenths, 3 of them have got a 1, but this one's got a 0. So this must be the smallest. The next one, so we've got all the same in the tenths, so we move on to the hundredths. And that's looking at this number now. So we've got a 0. So this one's next, 5.1. Then we've got a 5, say 5.152. And we've got a 6, 5.16. Question 7. Work out 15 minus 6 times 2. So this is a BIDMAS or a BODMAS question. So we need to get our order of operations right. And multiplication comes before the subtraction. So we're going to do the multiplication first. So 6 times 2, which is 12. And then 15 take away 12. That gives us 3. And work out the cube root of 27. So what number times itself and times itself again makes 27? And that's 3. 3 times 3 is 9. Times 3 is 27. So that means the cube root of 27 is 3. Question 8. There are only 15 beads in a bag. We've got 6 blue, 2 red, and 7 green. A bead is picked at random from the bag. Write down the probability that it is red. So there are 2 reds out of 15 in total. So the probability is 2/15. Write down the probability the bead is white. There are no white beads, so there's a 0 chance of getting a white bead. So the probability is 0. Question 9. Here are the first 5 terms in a sequence of a sequence. Find the next term. So we've got 14, 17, 20, 23, 26. We can see it's going up in threes. So if we add 3 on to 26, we will get 29. And part B, work out the 10th term of this sequence. So we could keep adding 3 on, or we could work out the nth term, which we'll do just for practice. So it's going up in threes, so it's like the 3 times table. And the 3 times table is called 3n. So it's the 3 times table. What are we doing to the 3 times table? To get our sequence, we are plussing 11 every time. So the sequence is called 3n plus 11. That's the nth term. If we want the 10th term, we change n into 10. So 3 times 10 plus 11, 30 plus 11, 41. Question 10. A is 5, B is 4. Work out the value of 3 A's plus 5 B's. So I've got 3 A's, which is 5, plus 5 B's, which is 4. So 3 5's is 15. 5 4's is 20. So that means 15 plus 20, which is 35. Question 11. Find 21% of 160 pounds. So we can find 10% by dividing by 10. So 160 divided by 10 is 16. So 16 pounds is our 10%. We can find 20% by doubling 10%. So 16 times 2 is 32 pounds. So 32 pounds is 20%. And we're going to need to find 1% to add it on. And we can either do 160 divided by 100 or 16 divided by 10. Either one of those. So 16 divided by 10 is 1.6, which is £1.60. £1.60 is 1%. So if we do 20% now, plus 1%, that's going to be £33.60. £32 plus £1.60 is £33.60. Question 12. So we've got coordinates. On the grid, mark with a cross the point 1, minus 2. So it goes x, then y. 1 on the x, minus 2 on the y. So 1 on the x, minus 2 on the y. So there's point C. Write down the coordinates of point A. So we do x first. So minus 3, 3. X, then y. Write down the coordinates of the midpoint of AB. So the middle of AB. So where is the middle of AB? We could use a ruler for this. Or we could look how far we've gone along. So from A to B, 1, 2, 3, 4, 5, 6 along. And 2 down. So half of that is, I'll write that 6, 2. 6 along, 2 down. Half of that is 3 along and 1 down. So 1, 2, 3, 1. So there's the middle. And the coordinates are 0 on the x, 2 on the y. So 0, 2. Question 13. Mo goes to a cafe. He buys 2 coffees for £1.80 each, 3 teas for £1.50 each, 2 cakes for £2.10 each. How much money does he spend? So we've got 2 £1.80s, which is £3.60, which is doubling 18, 36. 3 £1.50s, which is £4.50, and 2 £1.10s, 2 £2.10s even, £4.20. So we're just going to add these up. Zero plus 0 plus 0 is 0. 6 plus 5 plus 2 is 13. So we've got 3 and we'll carry 1 over. 4 plus 4 plus 3 plus 1 is 12. So that's £12.30. Question 14. A map has the scale of 1 to 50,000. The distance between 2 points on the map is 10 centimeters. Work out the real distance. Give your answer in kilometers. Kilometers. So if it's 10 centimeters on the map, so if I times the 1 by 10, I'm going to times the 50,000 by 10. So that would be 500,000 now. So it's 500,000 centimeters, but we need the answer in kilometers. So if I divide it by 100, that would change it to meters. So divide 100. So that's 5,000, taking off 2 zeros. 5,000 meters. And a kilometer, km, that means 1,000 meters. So how many 1,000 meters have I got? I've got 5 kilometers. 5,000 meters. Question 15. Work out 42 times 316. So we've got a multiplication question. It doesn't matter which method we use as long as we get the right answer. So I'm going to do a grid. So 4 times 3 is 12. Add on 3 zeros. 2 3s are 6. Got 2 zeros. 4 1s are 4 and 2 zeros. 2 1s are 2 with 1 0. And 4 6s, that's 24 plus 1 0. 6 2s are 12. So I just need to add up these answers now. So I've got 12,000, making sure I line this up. 600, 400, 240, 20 and 12. So 0 plus 0 plus 0 plus 0 plus 0 plus 2 is 2. 4, 2 and 1, that's 7. 6, 4 and 2 is 12. So 2, an extra 1 carried over. 2 and 1 are 3. And I've just got 1 in that column. So I've got 13,240 and 72. Question 16. In a bag there are blue sweets, red sweets and yellow sweets. The number of red sweets is 3 times the number of blue sweets. So we can write a ratio 3 to 1. The number of yellow sweets is half the number of red. So if we've got 3 red, half of that yellow, 1.5. Write down the ratio of blue to red to yellow. So we need to write it in a different order. And they all need to be whole numbers. So blue to red to yellow. Blue, red, yellow. So 1, 3, and 1.5. They need to be whole numbers, so I'm going to double them all. So 2, 6, and 3. Question 17. The table gives some information about the favourite sport of 30 students. So we've got boys and girls and we've got their favourite sport, and they want a suitable diagram, and that's going to be a bar chart. So a bar chart with a separate bar for boys and girls. So the highest number is 7. So we have 1, 2, 3, 4, 5, 6, and 7. And we're going to have football, rugby, cricket, and tennis. So that's room for the bars for football. Then we'll do a gap between them, and then rugby, then another gap, and cricket, then another gap, and tennis. So boys football is 6, and girls football is 7. So get a ruler. So boys football, boys is the first bar. And girls as the second bar. Rugby 5-3. Cricket 3-2. And tennis 1-3. Okay, we're going to need a key. So I'll write key, and we'll have boys, and we will do diagonal lines for the boys. And girls, we will just do full shading. Doesn't matter really what you do. And there's our bar chart. Question 18. On the grid, draw the graph of x plus y equals 4 for x values -4 to 4. So they haven't given us a little table to work out values. Sometimes they do, and it looks something like this. We could do all the values from -4 to +4, but we don't actually have to. So I'll just do 0 to 4. And if x is 0, so 0 plus what for y equals 4. 0 plus what number equals 4, which would be 4. 1 plus 3 equals 4. 2 plus 2, 3 plus 1, and 4 plus 0. And we can plot these on the graph. So 0, 4, 1, 3, 2, 2, 3, 1, and 4, 0. We have to extend the line all the way across the graph because it needs to go from -4 to +4. And there's our straight line. And that's done. Question 19. 3 packs of tea bags are available in the supermarket. So pack A, 240 for £5. Pack B, 200 for £4. Or pack C, 160 for £3. We're going to compare them. To compare them, we need to make something the same. So either the number of tea bags has to be the same, or the price has to be the same. And I think it's going to be easiest to make the price the same. I mean, we could try and divide them all by 40 for the tea bags. Or we could divide by 5, divide by 4, divide by 3 to get the price the same. Let's go with the price. So pack A, 240 for £5. So if I divide that by 5, 240 divided by 5 is the same as 480 divided by 10, which is 48. So it's 48 for £1. So pack A is 48 for £1. Pack B, 200 for £4. If I divide that by 4, 200 divided by 4 is 50. So that's 50 for £1. So 50 for £1 is better than 48 for £1. And pack C, 160 for £3. Divide that by 3. That doesn't actually go. So how many 3's go into 160? 3 goes into 1 no times. 3 goes into 16 5 times with 1 left over. And 3 goes into 10 3 times with 1 left over. And so on. So if we say that's 53 for £1 to the nearest tea bag, which is the best value for money? Pack C. Question 20. 100 students attended a revision lesson at the weekend. Each student went to maths or English or science. So they went on Saturday or Sunday to maths, English or science. We have a two-way table question. So it's Saturday, Sunday total, maths, English, science total. So let's fill in the table. 100 students in total. 55 on Saturday, which means 45 on Sunday. 40 went to maths. 12 of the 27 that went to science went on Sunday. So 27 went to science, 12 on Sunday, which means 15 on Saturday. 10 went to English on Saturday. So we'll just fill in the gaps now. So we've got 10 and 15 here, which is 25 on Saturday, but we need 55. So that's 30 more. In maths, we've got 30 on Saturday. We need 10 more to make 40 in total. And Sunday, we've got 10 and 12 at the moment, which is 22. So we need another 23. And 10 and 23 makes 33. How many students went to maths on Saturday? 30. Question 21. Work out 2/5 divided by 3/4. So to divide fractions, we keep the first one the same. We're going to change it to a times and flip over the second one. So 3/4 flipped over is 4/3. So dividing by 3/4 is the same thing as timesing by 4/3. And to times fractions, we times the top and times the bottom. So 2 4s are 8 and 3 5s are 15. Part B, adding fractions. To add fractions, we need to make the denominators, the bottom numbers, the same. So I'm going to times top and bottom of this one by 7 and top and bottom of this one by 5. And that'll make both the denominators the same because they'll be whatever 7 times 5 is. So 1 times 7 is 7. 7 times 5 is 35. 2 5s are 10. And 7 times 5 is 35. So I've got 7 of a fraction, 7 of something, plus 10 of something, which makes 17 of that same thing. So 7 35ths plus 10 35ths is 17 35ths. Question 22, solve. So I need to find out what x is. That's what solve means, find out the missing number. So I'm going to expand the bracket first. So I'm going to multiply both things in the bracket by the 3, which is on the outside of the bracket. 3 times x is 3x. 3 times 4 is 12. And that equals 19 still. I want to get x by itself. So I want to get rid of this plus 12. To get rid of a plus 12, we do the opposite of plus 12, which is minus 12, take away 12. So we subtract 12 from both sides. both sides of the equal sign. So on the left, we've got 3x left. And on the right, we've got 19 take away 12, which is 7. I want to get x by itself now. At the moment, it's multiplied by 3. So we do the opposite of multiplying by 3. We divide by 3. So if I divide both sides by 3, I can just write that as 7 over 3. I don't need to do anything with this. It's a perfectly good answer. So x equals 7/3. Question 23. The diagram shows a box. 5 of these are going to be painted, and a pot of paint covers 6 meters squared. How many pots of paint are needed to paint 5 boxes? So this is a surface area question. And well, we've got this in meters squared, and we've got these in centimeters. So we can change these into meters. So I have 1 meter, 0.4 meters, and 0.5 meters. So surface area is the area of every surface. So we've got this front. So the front is 1 by 0.5. So the area 1 times 0.5, which is 0.5. Now we've got exactly the same. The front is repeated on the back, so the back will also be 0.5 meters squared. The top now, so it's going to be 1 by 0.4. 1 times 0.4, which is 0.4 meters squared, and the bottom is the same as the top, so that's also 0.4 meters squared. And finally, we've got the side, 0.4 times 0.5, which is 0.2 meters squared. So 4 times 5 is 20, but we've got 2 numbers after the decimal point in the question, so we've got 2 numbers after the decimal point in the answer. And the other side is also 0.2 meters squared. So what's the total surface area? 0.5 plus 0.5, that's 1. Plus 0.4, 1.4. Plus another 0.4, 1.8. Plus 0.2, which is 2. Plus another 0.2, 2.2 meters squared. So the total surface area is 2.2 meters squared. And we're going to paint 5 of them. 2.2, 5 times. 2.2 times 10 is 22. Half of that is 11 meters squared. So we need 11 meters squared of paint. Each pot can cover 6. So we need 2 pots to cover 11 meters squared. 2 pots that can cover 6 meters squared each will cover 11 meters squared. Question 24. In a box there are blue pens, red pens and green pens. The ratio of blue pens to red pens to green pens is 5 to 3 to 2. Blue to red to green. There are 18 more blue pens than red pens. So There's 18 more blue pens and red pens. So we've got 5 parts for blue, 3 parts for red, and 2 parts for green. The difference between blue and red is 18 pens, and it's 2 parts. So 2 parts, or 2 boxes, must equal 18 pens. So 1 part must be 9 pens. So if there's 5 lots of 9 blue, there are 3 lots of 9 red and 2 lots of 9 green. How many green pens are in the box? 2 9s, 18. Question 25. 4 builders working 6 hours a day can build a wall in 2 days. So 4 builders working 6 hours a day, so that's 24 hours per day, and 2 days, so 24 times 2, 48 hours in total. So it takes 48 hours in total to build this wall. How many days will it take 2 builders working 8 hours a day? So if I've got 2 builders, that's 24 hours for each. So they need to do 24 hours of work each, and they're going to work 8 hours a day. 24 divided by 8, 3 days. State an assumption you have made. So the assumption is that the builders work at the same rate. All builders work at the same rate. Okay, question 26. So we've got parallel lines here. I did intend this to be a parallel lines question, but you don't actually need the parallel lines to solve it. So it's a bit of a mistake, but let's work it out anyway. A, B, and C, D are parallel. CEF is 124 degrees, so CEF, that's this one. EFG is 93. EFG, 93. Find the size of angle FGD. FGD. You must show how you got your answer. So we can use angles in a straight line to work out FEG. So 180, take away 124. So 20 to 70 is 50, and 6 more. So 56. Then we can use angles in a triangle way up to 180. So at the moment we've got, I'll write the reason here, angles on a straight line. Add to 180. We can use angles in a triangle to work out FGE. So at the moment we've got 93 and 56. 93 plus 56 is 149. So 180 take away 149 is 31 degrees. So we've got 31 degrees here. So FGE, 31 degrees, because angles in a triangle add to 180 degrees. And we've got angles in a straight line finally, so FGD is 180 take away 31, which is going to be 149. And that's our answer. Question 27. The average daytime temperature for 10 days is recorded. And ice cream sales are also recorded for the 10 days. And we've got a scatter graph to show that information. What type of correlation do we have? So with a scatter graph, we can draw a line of best fit, as long as there is a correlation. And there is a positive correlation. So it's going up, from left to right going up. That makes it a positive correlation. And we can draw a line of best fit with approximately the same number of points on each side. So what correlation have we got? It's going up. It's a positive correlation. One of the points is an outlier. So you can see one of the points is a long way away from the line of best fit. So what are the coordinates? So we're at 20, halfway between 20 and 25, which is 22.5, and halfway between 50 and 100 is 75. So it's 22.5, 75. On another day, the temperature was 12 degrees. Estimate the sales, ice cream sales, on this day. So 12 degrees. We're going to use the line of best fit. So it's going from 2, so that's 11, 12. Go up to our line. And then along. And we'll call that 110. We'll call that 110. So whatever we get from reading off of our line, as long as we've got a good line and we've read off it correctly, the answer should be fine. So just under 110 is what I've got from my graph. Question 28. So we've got A, B, and CD are parallel lines. AD and BC are straight lines, so two parallel lines with two straight lines going between them. AB is 6 centimeters. CD is 4 centimeters. BE is 9 centimeters. So we've got similar shapes here, and we know they're similar shapes because we've got opposite angles here, and opposite angles are equal. We've got alternate angles here and alternate angles here. So we've got 3 angles the same, so we know they are similar shapes. One is an enlargement of the other one. So we've got a small shape, EDC. We've got 4 centimeters along the bottom. and we've got the bigger shape, E at the top again, and on the left would be A, and on the right B. So angle D goes with angle A, and angle B goes with angle C. And we've got 6 centimeters here, and BE is 9 centimeters. So we've got similar shapes, so we can work out a scale factor. So what do we times the little shape by to get big shape? So what do we times 4 by to get 6? Because these two lengths go together. What do you times 4 by to get 6? So you can do 6 divided 4 to work that out, which is 3/2 or 1.5. So to get from small shape to big shape, we times by 1.5. To go back the other way, divide by 1.5. So the length of CE, so we're going back, 9 divided by 1.5. How many 1.5s make 9? 6. AD is 12.5 centimeters. AD, that's the entire length. Is 12.5 centimeters. Find the length of AE. So if we have X as ED, AE is going to be X times 1.5, which is 1.5 X's. And these two lengths, ED is X, AE is 1.5 X. So those two lengths add up to make 12.5. So X plus 1.5 X equals 12.5. 1 plus 1.5 is 2.5. And if I divide both sides by 2.5, how many 2.5s go into 12.5? That's 5. So my ED is 5. So AE is 5 times 1.5, which is 7.5. Question 29. So we've got estimate. Whenever we see that, we know we're rounding. So we then want to work out the actual length of AB. We're going to use rounded numbers. So if I round these to one significant figure, or the nearest number in this case, so 10.2 to the nearest number is 10, and 7.6 to the nearest number is 8. And we're working at AB. So it's a Pythagoras question. So x squared plus 8 squared equals 10 squared. So x squared plus 8 squared is 10 squared. So x squared is 10 squared. Take away 8 squared. And 10 squared is 100. 8 squared is 64. 100 take away 64 is 36. So that's x squared. So we need to square root that. And the square root of 36 is 6. Is our answer an underestimate or an overestimate? So is the actual length going to be bigger or smaller than 6? So we rounded the 10 down, and we rounded the 8 up. So we made this number smaller, and we took away a bigger number. So our answer is an underestimate. We made the answer too small. So 10.2 squared take away 7.6 squared will be more than 10 squared take away 8 squared. So I'll write that 10.2 squared take away 7.61 squared will be bigger than 10 squared take away 8 squared. So our answer is an underestimate as we rounded 10.2 down and 7.61 up. So the actual answer will be bigger than the answer we got. Question 30. ABCD is a parallelogram. Everything's in centimeters. The height is 5 centimeters. Find the area. So we need to work out the lengths, A, B, and CD, and we know that they are the same. The opposite sides of a parallelogram are the same length. So we can make this into an equation and say that this one equals this one. So 3x plus 5 is equal to 5x minus 9. We can solve this equation. So we're going to get rid of the smallest x first, which is the 3x. So take away 3x from both sides. And that leaves us with 5 equals 2x minus 9. We want to get x by itself. So we need to get rid of this minus 9, get rid of this subtract 9. And the opposite of taking 9 away is adding 9. So we add 9 to both sides, which leaves us with 14 equals 2x. And divide both sides by 2, so x is 7. So what's the length? Well, the length is 3x plus 5. So 3 times 7 plus 5. 3 sevens are 21, plus 5 is 26. So this is 26. We want the area. So the area of a parallelogram is just the length times the height. So 26 times 5. (26 times 10 is 260, and half of that is 130. No units are here, so we need to write them on. And it was in centimeters, so the area is centimeters squared. Question 31. Last question. Solve the simultaneous equations. So we need to either get rid of x or y, and we do that by making something the same. So if I make the x's the same, and I'll do that by multiplying the top one by 3 and the bottom one by 5. So the whole top line times 3 and the whole bottom line times 5. So 3 5s are 15. 3 2s are 6. And 3 24s, that's 72. The whole bottom line times 5. 5 3s are 15. 5 times -1 is -5. And 5 21s is 105. So now I'm going to take these away. 15 take away 15 is nothing. 6 take away minus 5. So 6 plus 5 is 11. So 11y's. And 72 take away 105. It's going to be negative. And that's 33. So 11y's are minus 33. Divide both sides by 11. Y is negative 3. So we know y. We need to find x. So we're going to substitute in. Let's pick the top one. 5x plus 2y's. And y is negative 3 now. Equals 24. So what's 2 negative 3's? That's negative 6. So plus 6 to both sides. That's 30. And divide both sides by 5. X is 6. And we can check that in our second equation. So 3 6's are 18. Take away minus 3. 18 take away minus 3 means 18 plus 3, which is 21. And we know we've got it right.